Hey there, math fans. Today we're going to talk about functions. Anyways, a function is a relationship in which each member of the domain is paired with exactly one member of the range. So if you recall, domain is all the x values, range is all the y values. So basically each x value only has one y value that corresponds to it. So x values cannot repeat, but y values can. What we're going to do is we're going to go through lists, some mapping examples, and some graphs to see if we can tell if something is a function or not. So first we start with a list. Now for a list, what we need to do is we need to check all the x values first. If the x values do not repeat, then it is in fact a function. If the x values do repeat, then we need to look at the y values. If the y values are the same, then it's the same point and it remains a function. But if the y values are different at that point, then it is no longer a function. So let's look at this one. Our x values are 5, 7, 9, and 11. What do you think? Yes, it's a function. I know, very exciting graphics today. Right? Okay, let's look at another one. I'll give you a second to take this in. Okay. So our x values, 1, 3, 1, and 6, you can tell that 1 and 1 repeat. Well, after they repeat, that doesn't immediately say it's not a function. Now we have to look at the y values. Well, the y values are also different, 4 and -5, which means these are not the same point, which means that no, this is not a function. All right, take a second to look at that one. So our x values are 5, 7, 5, and 8. Okay, 5, 7, 5, and 8. So our x values do repeat, but then we look at the y values on those repeated x values, and they're both 6. So this is the same point. So in fact, this is a function. All right, now we're going to talk about mapping. Okay, so mapping is just a graphic to show x values go to y values. So on this graphic, x is 1 is mapped to y equals -2. X is equal to 2 is mapped to y equals -4, and so on and so forth. This one, you can tell that each x value only has one y value, so yes, this is a function. How you can tell that is because there's only one arrow coming off of each x value. So that would mean this one, we have 2 arrows coming off of x is equal to 3. So that means that x equals 3 is mapped to y equals 9 and y equals 10. So no, this is not a function. How about this one? This one's a little different, okay? But how many arrows come off of each of the x values? That's right, 1. And because only 1 come off of each x value, none of the x values actually repeat. So yes, this is a function. All right, so we've gone over lists and mapping. Now we're going to look at graphs. So we've got this graph, okay? For graphs, we're going to do something called the vertical line test. Now what the vertical line test does is we take a vertical line, like this ruler, and we're going to pass it from left to right over the graph. If at any time the graphed image touches my vertical line in more than one place, then it is no longer a function. So I start here on the left-hand side, and you can tell as I bring that across, only one point on the graph touches that at the same time. So yes, this is a function. Ooh, this one's a curve. Right, you see it's a curve, but we still do our vertical line test from left to right. At any point, did more than one part of that graph touch my vertical line? Nope. So yes, it is a function. All right, this one, another curve. We take our ruler from left to right, and you can tell for pretty much this entire graph, it touches my ruler in more than one spot, and 2 to be precise. So no, it is not a function. So there's a quick introduction to functions. I hope that helps you to understand how to tell if it is a function or not.